Basic concepts. Operating system OS. The master control program in a system. Manages all software and hardware resources. Controls, allocates, frees and modifies the memory by increasing or decreasing it. Also manages files, disk and security, provides device drivers and GUIs for desktop or mobile computer, other functions and applications. Enables the assignment of priorities for requests to the system and controls I/O devices and network. Has the utility programs, for example, file manager and configuration of OS, memory and resource allocation, and enabling and disabling the use of specific resources and functions. Can be accompanied by a specific suite of applications, for example, Internet Explorer and MS Office. Mobile operating systems. An OS which enables running of application tasks taking into account constraints, for example, the constraints of connectivity, CPU speed, memory, battery life, display, and size of input devices of hardware and network. Enables a programmer to develop application without considering the specifications, drivers and functionalities of the hardware of the system. Enables an application to run by simply abstracting the mobile system hardware. Enables the programmer to abstract the devices such that the application need not know full details of the font and font size of the mobile device display. Facilitates execution of software components on diversified mobile device hardware. Application need not be aware of the details of the LCD driver and memory at which the CPU will send the message for display. Provides interfaces for communication between processes, threads, and ISRs at the application and middleware layers. Provides middleware for the system hardware. Provides management functions such as creation, activation, deletion, suspension, and delay for tasks. Provides memory management. Enables running of processes and helps the processes in obtaining access to system resources. Mobile OS example. Palm OS, Symbian, Windows CE, Android released in 2008 by Google, open source code which powers mobile operating system. Operating system functions. All operating systems provide functions to perform the following actions. Task management. Functions include task creation, blocking, running, delaying, suspending, resuming after suspension or delay, and deleting. A task is created using a name and is assigned an ID. Task is blocked if time slice allotted by OS to task is over or suspended by an instruction. Task execution resumes using an instruction or after delayed period is over. Deleted by an instruction or when it is no longer required in the system. Memory management. Functions are allocation, freeing, and deallocation. Distant memory addresses are allocated for the code, data, stack, and control blocks of each task. Memory addresses allocated earlier may require to be deallocated. When a program runs, additional memory may be needed by new tasks or memory buffers. OS deallocates unused memory addresses and allocates to new tasks. Device management. Functions are for device creation, configuration, initiation, registration, reading, listening, writing, acceptance, deregistration, and deletion. Once a device is created, a device descriptor is specified for the device. A device is configured as per application requirement. Device is initiated at start. Device registering with the OS means that the device can send messages through OS for other tasks or receive messages through OS. Device memory buffer is read from present memory pointer or cursor position. A device is said to be listening when it is executing after waiting for a request from another device or task. May accept a request for listening from another device or task. Device may be deregistered with the OS, which means OS cannot send or receive messages. File management. Functions are creating, opening, closing, read, write, and delete. A file is created and a file descriptor is specified. Descriptor is a data structure having information of file name, file size, file creation date and time, file author, last modification data and time. File is configured for read and write, read only or write only, or read with a password. A file is written, the records. Records are read from the file, which may be text, strings, or numbers. Database connectivity. Functions for database connectivity may be provided by the OS. Database, after connection to an API, is used for sending queries, for appending, deleting, or modifying the records, for reading and writing. I/O devices subsystems management. Functions of the OS manage the following subsystems: display, LCD or touchscreen, printer, SD or micro SD card, USB ports. Network subsystems management. Functions of the OS manage the following network subsystems: Ethernet, Internet, Wi-Fi. Middleware. Operating system also provides functions to perform middleware actions. Middleware means software that functions in between application software and a system that may be working on different operating systems. Middleware has integrated the OS in the advanced operating systems. Functions of middleware. Used for communications using TCP/IP protocol. Used for communications between mobile device and CDMA or GSM network. Sends requests to the service provider network and receives the maps of present mobile location from the network. Key applications and APIs. Operating system also provides functions to include the key applications: clock, mail, Internet Explorer, MS Office, and Bluetooth are some of the key applications provided by the OS. Synchronization software for Bluetooth device discovery and synchronization may be provided by the OS. APIs for access to the maps from the external library at the network. Communication options: USB port, Wi-Fi, CDMA, and HTTP. Applications such as Yahoo Messenger, Yahoo Mail, Facebook, Twitter, Gmail, etc. Abstraction APIs. An OS enables an application to run using an API. API simply abstracts the mobile system hardware. Enables programmer to abstract the devices so that the application need not know full details of the abstracted device, like the font type and size for display at the mobile device and how the message will be displayed by the LCD hardware. GUIs and VUIs. An OS may have provisions for APIs for creating graphic user interfaces (GUIs), may have provision for APIs for creating voice user interfaces (VUIs). Process. A program unit which runs when scheduled to do so by OS and each state of which is controlled by OS. Can call a function method but cannot call another process directly. States of a process can be in any of the states: created, active, running, suspended, pending for a specified time interval. pending state of a process for a specific communication from other process. Signal, semaphore, mailbox message, queue message, socket. Task. An application process which runs according to its schedule set by the OS, each state of which is controlled by OS. Can be a real-time task which has time constraints or maximum defined latency within which it must run or finish. Thread. An application process or a process subunit when a process or task has multiple threads. Runs as scheduled by the OS. Each state controlled by OS. Runs as a lightweight process. Lightweight does not depend on certain system resources, for example, Memory Management Unit MMU, GUI functions provided by the OS, or the functions which need running of other processes or threads for their implementation. Requirements. Operating system requirements. To be used efficiently, all computer software needs certain hardware components or other software resources to be present on a computer. These prerequisites are known as computer system requirements. Defines two sets of system requirements, minimum and recommended. The most common set of requirements defined by any operating system or software application is the physical computer resources, also known as hardware. Hardware requirements. A hardware requirements list is often accompanied by a hardware compatibility list HCL, especially in case of operating systems. An HCL lists tested, compatible and sometimes incompatible hardware devices for a particular operating system or application. Various aspects of hardware requirements. Architecture. All mobile operating systems are designed for a particular mobile computing architecture. Most software applications are limited to particular operating systems running on particular architectures. Although architecture-independent operating systems and applications exist, most need to be recompiled to run on a new architecture. Memory. All software, when run, resides in the random access memory RAM of a device. Memory requirements are defined after considering demands of the application, operating system, supporting software and files, and other running processes. Optimal performance of other unrelated software running on a multitasking device is also considered when defining this requirement. Palm OS. An OS for handheld devices. Designed for highly efficient running of small productivity programs for devices with a few application tasks. Offers high performance due to a special feature that it supports only one process which controls all computations by the event handlers. No multiprocessing or multitasking. Simplifies the kernel of the OS. There is an infinite waiting loop in the only process that kernel runs. The loop polls for an event. Each polled event sends interrupt signal handled by an event handler. Functioning as non-maskable, non-prioritized ISR. Example, polling for the events. For a request to run an application or sub-application. For a search program, request to process a query. Notifications like timeout alarm. GUI actions such as touching or tapping the screen with stylus. Palm OS features. Single process, no multiprocessing and multi-threading. Compiled for a specific set of hardware, performance very finely tuned. Memory space partitioned into program memory and multiple storage heaps for data and applications. A file and format of a database. IP-based network connectivity and Wi-Fi in later version only. Integration to cellular GSM CDMA phone. Palm OS hardware support. compiles for a specific set of hardware. Its performance is very finely tuned, optimized to support a very specific range of hardware, CPU, controller chips, and smaller screens of Palm OS-based devices. Display screen support. Generally widescreen. 160 into 160 pixels. Optimized layout of desktop programs displayed on screen. 256 color touchscreen. Higher resolution support in new versions. Palm OS memory support. 16 MB memory. 256 MB internal flash, non-volatile ROM. 256 MB card consisting of flash memory which the user inserts into the device. The card, RAM, ROM and flash memories. RAM for stacks of processes and for the global variables in the running processes of the applications. ROM or flash for permanent resident application programs and OS. Flash used for storage of non-volatile data. Direct memory address spaces in card used instead of allocated dynamic memory buffers for the I/O ports devices. Example, LCD display, keypad input and modem I/OS. Palm OS memory space partitions. Program memory dynamic heap for process stacks and global variables. Multi-storage heaps for data and applications. File manager. Manages each file as a database which has multiple records and information fields. Each record attributes protected record, deleted record, similar to deleted file, locked record, in use by application process or OS, and updated record. Deleted record attribute helps in data recovery by a recovery program. The info fields of each record. Record ID and record attributes. Info fields about the file have name, file attributes, version of application database, modification number, number of times modified, and access counter for number of times accessed, file local ID, a number used to identify the file locally when an application is running, in place of several characters requiring several bytes. File ID. A local file sorting table uses the file local ID to sort the file in the required order. For example, the ordering may also be based on the time and date of the last modification made in the file. Palm OS file format. Format of a database. Multiple records. Information fields about the file name, attributes, and version of the database for the application. Palm OS connectivity. IP-based network connectivity. Wi-Fi in later version only. Wireless communication protocols. Integration to cellular GSM CDMA phone. Palm OS APIs. Simple APIs compared to Windows CE. Simple APIs for developing the GUIs, buttons, menus, scroll bar, dialogues, forms and tables. Using HTML markup language. Palm OS desktop and desktop program. Desktop for Windows and Mac both and other essential software. SMS, address, card info, hotsync, to-do list, SMS, security, datebook, calendar, calculator, welcome and clock. Palm OS PIM. Address book, data book for task to do an organization, memo pad, SMTP, simple mail transfer protocol, email download, offline creation and sending of POP3, Post Office Protocol 3 email, Internet browsing functions using Blazor, a browser for handhelds. Windows Organizer. PDA, Personal Digital Assistant. Palm OS Query Development Platform. Query Development Support Platform. Palm Query Applications. PQA, written using HTML and ported at Palm device. Palm OS Client-Side Applications. GUI Development Support on C, C++ platform using Palm SDK. For Java application using J2ME and advanced tools, for example, Metrowork Code Warrior. Multimedia applications such as playing music, Palm Tungsten. Palm OS Port. Serial and infrared ports for communication with mobile phones and external modems. Synchronizing a PC personal area computer using HotSync after resolving the conflicts in different versions of files during data exchange. Port protocols. IRDA or serial device. System mounted on a cradle. Connects to computer PCs through IR or serial port. A cradle is an attachment on which the handheld device can rest near a PC and connects to the PC via a USB or infrared. Device handling. Assumed as a new flash drive of a PC. HotSync facilitates drag and drop of files from device to PC and vice versa. Third-party applications support. Games, travel and flight planner, calculator, graphic drawings, preparing slideshows. Communication APIs for serial, IRDA and TCP/IP communication. Serial communication uses a cradle. Protocols. Connection Management CM Protocol. Modem Manager MM. Serial Link Protocol SLP interacts with SM to transmit the data to PC. A device receives the data from the other end through Serial Manager and SLP, MM or CM. Communication Protocols. MM for deploying a dial-up modem. CM carries out exchanges for establishing connection, baud rate selection and finding version number. SLP for packet communication on serial line. A desktop link protocol DLP transmits data to PADP when serial device is sending data to PC and receives data from PADP when serial device is receiving data from the PC. Applications. SMS, address, card info, HotSync, to-do list, security, date book calendar, Calci, welcome and clock. Application development packages. Supports development packages Palm SDK Software Development Kit and CDK Conduit Development Kit. A conduit is a path which provides a two-way path for data exchanges and synchronization between a desktop PC application for Windows or Solaris and the applications running on a device. OS and hardware layer in architecture layer of Palm OS. Lowest level layer in OS. Kernel directly interfaces the assembler firmware software installed in the hardware devices in the system and hardware. Palm OS has a microkernel. Palm OS 4.x adds improved security, improved GUIs, VUIs, telephony libraries, standard interfaces for access to the external SD card for the files. Palm OS 5.x supports a standardized API for high-resolution screen, dynamic input areas instead of persistent battery back, RAM, a non-volatile file system using flash memory, saves the files and data in case the battery charge is draining out. ARM, the processor, providing efficient code and an energy-efficient architecture. Advanced Palm OS handheld. merged PDA and smartphones. Feature to double as a hard drive using USB cable to PC. Enables the drag and drop of files between the Palm and PC in a manner similar to the drag and drop function in a PC between C and D drives. Recent developments. Integration in Windows CE. A few Windows mobile handheld devices in use are Palm lookalikes, but these do not deploy Palm OS platform but Windows CE. Palm OS deficiencies. Instead of multitasking, Palm OS provides for running a sub-application from within an application. Not an ideal platform for running multimedia applications because due to Palm OS is not for designing real-time systems, does not offer much expandability. Inability to adapt to different sorts of hardware may also be considered a limitation for this operating system. Various aspects of hardware requirements. Architecture. All mobile operating systems are designed for a particular mobile computing architecture. Most software applications are limited to particular operating systems running on particular architectures. Although architecture-independent operating systems and applications exist, most need to be recompiled to run on a new architecture. Memory. All software, when run, resides in the random access memory RAM of a device. Memory requirements are defined after considering demands of the application, operating system, supporting software and files, and other running processes. Optimal performance of other unrelated software running on a multitasking device is also considered when defining this requirement. Various aspects of hardware requirements. Processing power. Processing power and capability of a mobile device is a fundamental system requirement for any software. Secondary storage. External memory support requirements vary depending on the size of software installation, temporary files created and maintained while installing or running the software, and possible use of swap space if RAM is insufficient. Display adapter. Software requiring a better than average graphics display like graphic editors and high-end games often define high-end display adapters in the system requirements. Example: Android OS hardware requirements. The Android mobile operating system is Google's open and free software stack that includes an operating system, middleware, and also key applications for use on mobile devices, including smartphones. The main hardware platform for Android is the ARM architecture, ARM v7 and ARM v8A architectures, with x86 and MIPS architectures, also officially supported in later versions of Android. Requires a minimum amount of RAM for devices running Android 5.1 range from 512 MB of RAM for normal density screens to about 1.8 GB for high density screens. The recommendations for Android 4.4 is to have at least 512 MB of RAM, while for low RAM devices 340 MB is the required minimum amount that does not include memory dedicated to various hardware components such as the baseband processor. Android 4.4 requires a 32-bit ARM v7 MIPS or x86 architecture processor, later 2 through unofficial ports, together with an OpenGL-ES 2.0 compatible graphics processing unit GPU. Android supports OpenGL-ES 1.1, 2.0, 3.0 and 3.1. Some applications may explicitly require a certain version of the OpenGL-ES, and suitable GPU hardware is required to run such applications. Android devices incorporate many optional hardware components including still or video cameras, GPS, orientation sensors, dedicated gaming controls, accelerometers, gyroscopes, barometers, magnetometers, proximity sensors, pressure sensors, thermometers, and touchscreens. Some hardware components are not required but became standard in certain classes of devices such as smartphones, and additional requirements apply if they are present. Symbian OS. OS for handheld smartphones and mobile handhelds with phone and multi-modal communication features. Multimodal means usage of different modes: text, image, video, or audio. Multimodal communication integrates and synchronizes multimedia, video with text, audio with text, etc. Supports application development in C, C++, as well as Java and many communication protocols. Symbian OS performance fine-tunes to ARM processors, which are used in about more than 70% of mobile devices, for example, Nokia mobile devices. Symbian application development languages: Personal Java, Java JVM, Java Micro Edition and MIDP, Mobile Information Device Profile, Java Phone, HTML, CSS and JavaScript combine to enable rapid application development. JavaScript extensions provide access to core device functionality such as camera and contact using PhoneGap. Symbian Everywhere C, C++ OS functions. Symbian C++, Python, Adobe Flash, GUI development support on C, C++ and Java platform. SyncML, Web Runtime WRT, integration of Chrome V8 JavaScript engine into the browser application, WebKit application framework and IBM WebSphere Everyplace access. Symbian application tools: Standard C++, Application View, Application Engine, Platform Development Kit S3 PDK 3.0.4, Qt Framework with Integrated Development Environment, Qt Creator, Qt Quick and QML, JavaScript-based language for Carbide C++ IDE for Symbian-specific C++ as the development environment with Symbian C++ Software Development Kit SDK. New Qt-based browser. Symbian key features: PIM, contacts, push-to-talk, slideshows, web push email download, address book, spreadsheet, calendar, agenda, word processor, text-to-speech converter, internet browsing, Wi-Fi, WLAN support, messaging, SMS, MMS, email, and IMAP4, Adobe Reader for accessing PDF files, offline creation and sending of POP3 email, multimedia applications such as playing music and video files. Symbian key applications: desktop both for Lotus and Windows programs, Microsoft Office formats and other essential software, high-end security enhancement features like Symantec Client Security 3.0, Fujitsu M-Process Business Process Mobilizer, BlackBerry Connect, Oracle Collaboration Suite, secure mobile connection via VPN client. Application development tools: Personal Java and Symbian Everywhere, Symbian C++ Software Development Kit SDK, Symbian Emulator for application development using Windows MetroWorks Code Warrior. Features of Symbian OS, APIs and application development environment: Communication and network APIs, WAP, Wi-Fi, CDMA, TCP/IP, communication APIs for HTTP, TCP/IP, DNS, SSL, WAP, PPP, IRDA, Bluetooth for communication with mobile phones and external modems. Network ports and connectivity: Internet connectivity for web browsing, Facebook and Skype, Java phone and integration to cellular, GSM, CDMA, GPRS phones. Intelligent network management: performance as per user needs, optimized for high speed when uploading photos or while using streaming video during a VoIP call or video feed, manages transition between cellular and Wi-Fi networks. Symbian Web Runtime Environment, WebKit Application Development Framework, new Qt-based browser, one-click connectivity, Web 2.0 support, YouTube. Organizer, organize pages as per user choice, choice of many email accounts, choice of feeds from friends, choice of weather forecast feeds. Memory, large storage memory, includes 80 MB of built-in memory in a multimedia card MMC. MMC multimedia card, SD secure digital memory card, and SDIO secure digital input-output memory card. GUI VUI user interface, powerful GUI development tools, APIs for the buttons and menus, new 2D and 3D graphics architecture, APIs for buttons, menus, advanced voice features such as hands-free speakerphone and conference calling ability, multimedia images, graphics, HDMI. Home screen, supports personalized user home screen to fit user choice, enables easy discovery of new widgets, provides animated live wallpaper, supports network feeds like feeds from friends and weather. Multi-touch screen, support for multi-touch gestures, example pinch to zoom, ease of use of improvements right across the platform, swipe to scroll, pinch to zoom, tap to open. Easy navigating, supports video calls using Skype. Display resolution, layout of desktop programs displayed on screen and 256 and high color touchscreen. Third-party support, games, travel and flight planner, enterprise solutions, calculator, graphic drawings, preparing slideshows. Multitasking, concurrent browsing of the web on mobile, uploading photos from mobile, listening to internet radio. Symbian OS features, SyncML synchronization, can also deploy C, C++ based synchronization software. Low boot time. OS supports multiprocessing or multitasking and multi-threading. Internet connectivity for web browsing, IP-based network connectivity and Wi-Fi in later version only. Integration to cellular, GSM, CDMA phone. Symbian supports a standardized API for high-resolution screen, non-volatile file system using flash memory to save the files and data instead of saving them in persistent battery-backed RAM. ARM, the processor which provides efficient code and an energy-efficient processor architecture. Figure below shows OS and hardware layers of Symbian. Conclusion. In this chapter, we have covered the following in detail. Basic concepts. Requirements. Symbian OS, Palm OS,